Hello, this is Mr. Novak. Today you're going to be learning about kinetic and potential energy. So just kind of as a background, we've already started working on, previously we've been working on work and power, and that kind of builds on to what we're going to be learning today with kinetic and potential energy. So let's take a look here. So the first thing we need to know about is energy. So energy is the ability to do work, and the unit for energy is joules. So as you remember, as we were working on our problems with work, uh, the formula for work was force times distance, right? The ability to do a force over a distance. And the unit for work was joules. So it makes sense that in order for us, if energy is the ability to do work, it also would be measured in joules. So they're both measured in joules. So just kind of something that we've done already. And there are two basic types of energy. There is potential energy and there's kinetic energy. And as we go along, you'll see we'll get into more specific types of energy. But right now, the most important thing is to kind of understand that there are two basic types and they will fall into those two categories, potential and kinetic. So our first one here we're talking about is kinetic energy. So kinetic energy is the energy that an object has when it is moving. The kinetic energy of an object depends on its mass and its velocity. The formula for kinetic energy is equal to 1/2 times mass times velocity squared. So kind of the basic thing here is as the velocity or the speed increases in an object, the amount of kinetic energy will increase. And as the mass increases, the kinetic energy increases as well, which kind of makes sense. If it gets bigger, it's going to have more energy. If it goes faster, it's going to have more energy. So the main thing here is kinetic energy is anything that is moving. So as we take a look here, there are two examples of kinetic energy that I have here. So first we have a car going down a hill. So as a car is going down the hill, it's moving, so therefore it has kinetic energy. Pretty basic. Number two, a cheetah running. So he's running in the grass here, and you can see he's moving. You can see his legs are up, and you can see kind of the dust coming up over there too. So he's moving. It has kinetic energy. So anything that is moving has kinetic energy. So what's the difference between kinetic and potential energy? So potential energy is stored energy that results from its position. So the basic thing is it's not moving, okay? But it has the potential to do work, okay? So an object does not have to be moving to have energy. It just hasn't been used yet. So here are two examples of potential energy. So we talked about the car before. So a car at the top of a hill has potential energy because it hasn't started moving yet, and it has a lot, as you can see here with the hill. It has, because of the height of the hill, it has lots of potential energy because it has the force with gravity and the height. It has the potential to do anything, to move, or it has the potential to do work, but it hasn't done it yet. So the highest part right here of the hill, that's where the most potential energy will be. And our second example is something that I'm sure you've done before, is a rubber band being pulled back. So the energy is going from the person's hand and it's being transferred into the rubber band. So as that rubber band is pulled back, it has potential energy before it gets released. When it gets released, it would then have kinetic energy, but when it's being pulled back, it has potential energy because it's not moving and it hasn't been used just yet. So there are two types of potential energy, and the first one we'll have is gravitational potential energy. So potential energy related to an object's height is called gravitational potential energy. Sometimes we'll hear it called GPE for its abbreviation. So if you hear me say that, that's what it stands for. And if we look at the rock here, the rock has not fallen off of the cliff here yet, but its potential energy is solely because of its height. Because of how high it is off the ground, it has a lot of potential energy, has a lot of gravitational potential energy. So before it falls, right, because if it starts to fall, then it would have kinetic energy. But because it's at the top and it's not moving just yet, it has a lot of potential energy, and specifically gravitational potential energy. And our last example of potential energy is elastic potential energy, and that deals with objects that can be stretched or compressed. So as you can see here in this picture, we have a spring. So a spring, if it's staying still, is not going to have energy, but if it gets compressed, so if it gets pushed down, right, if it gets pushed down here, it will have potential energy, because if I push it down, after I let it go, it'll have kinetic energy and it'll move back to its original place, I should say. Same thing if it's being stretched out. If it gets stretched out, it has potential energy and elastic potential energy, and it'll have that until I release it, and then it will have kinetic energy because the spring will start to move. So other things that have elastic potential energy would be anything like a slinky, a rubber band that we talked about already, like a bow and arrow. If you hold the bow and you put it all the way back and you stretch it out, that would be elastic potential energy. So really, this is just kind of our first look into energy, and we're looking at those two types, kinetic and potential. And that's really our focus, is to kind of make sure we have an understanding between these two types. After we have an understanding of those two types, then we'll get into more specific. So that's all our notes for today. So once again, this is Mr. Novak signing off. Have a great day.